all of that off the top of his head, but I've known Joe a long time. It's not amazing, actually. Our next presenter will be Eric Holder, and after Eric is completed, then we'll have a chance for the panel session. Eric?
Sounds good. Thanks, Lee. Okay. I appreciate the chance to talk to everyone out there today. My name's Eric Holder. I'm working at the Fraunhofer Institute for Communication, Information Processing, and Ergonomics in Germany. I'll talk to you today about the display options for head-up information in the maritime world. Okay. We all see the definition for e-navigation probably a million times in the last 5 or 6 years. But if you ask the different people, I think there's still a lot of unclarity about what it means to this person or this person or this group or this group. So I'd like to start out with just saying, to me, what the underlying principles of e-navigation are. And part of that is getting in touch with the intended maritime users. What are their goals, their tasks, and their needs? Understanding this in the context that they'll be using things. And then providing these stakeholders with support. And that could be information or tools to complete these goals or tasks safely, efficiently, satisfactorily, intuitively as possible. Okay, the other word that's a big word in the definition is harmonization. I don't know if they've ever sat people down and asked them what harmonization means, but basically it means to bring things into agreement, if you ask Webster. So the questions to ask with that is, what are you harmonizing? What's being harmonized? And that would be this information or service that is or in the future might be available. And what are you harmonizing it with? And that should be this task or the goal that the maritime stakeholder is trying to achieve, either now or in the future. And then how should you do this harmonization? In a way that supports that task or goal. Make this clear, complete, intuitive, prevent the errors and misunderstandings, avoid things like clutter and overload. And the point of all this is to bring us to why to consider maritime head-up display information. I'm going to turn this one off so we don't have a double microphone. One of the tasks with more information on board that's falling away from the mariners is just keeping the watch out the window. And pretty much the only way to provide supplemental information while supporting this primary task of keeping your watch out the window is to use this head-up display concept. So that's what brought it into interest originally and said, can this be a viable technology for maritime use? And the first steps towards doing this, we've already done in conjunction with Cal Maritime here, and that was in their simulator to test the idea of head-up display in the maritime context. What is the concept of operations? How would this work? What information would be required? Does this show value? What do the mariners think about it? And value was shown, particularly in certain situations, such as reduced visibility, confined waters, and these high-speed operations where it's very dangerous to be looking down. The primary benefits you see are integrating this essential information where the mariners need it, making information visible that is either hard to see or invisible or augmented, and also reducing the time that the mariners are looking down. There's also concerns with this technology, and these are primarily in terms of clutter and just will the mariners accept this on board their ship and the constraints that could come with it. These are just some quick pictures of some of the testing that's been done at CMA in the simulator environment. You guys saw this yesterday, although I think it ended at the first waypoint because it wasn't set up just yet. Okay, so the simulator. I'm not saying it was easy to do in the simulator, but it's rather straightforward because you're presenting the information directly on the same image plane as the simulator. This cuts out a tremendous amount of the real problems that you have when trying to present head-up information. You don't have the problem of parallax where two different viewers are seeing two different images, or even the same viewer with both eyes seeing different images. You don't have as much focus and accommodation. You don't have glare. All these things are eliminated in the simulator. But as you want to move this into a real technology, I mean, the goal is something that mariners can use on board. To get it on board, you're going to have to start to address these problems. And today what I'm going to talk about is the different ways that that might be brought on board. Okay, there's 3 primary options of bringing head-up information on board a ship. And I sort of named them myself, so you guys can pick on the names later, but the basic idea is you have what I'm calling combiner-based displays, where you usually have a system of optics behind it, and you're presenting information to the mariner, but this information appears as if it was focused in another place, or it is able to be focused as if it was somewhere else. It's not set in the display itself. You have fixed position transparent displays, which is the equivalent of if you take your desktop monitor and make it see-through. The information is there, though. It's in the monitor plane. And you also have the wearable or the movable head-up, or excuse me, head-worn or head-mounted display option. That would be your third option. There's other ones such as projecting the image directly on your eye or video-based displays, but those are not going to be covered today. Okay, so those are the three primary options. Jump past the slide here. Oh, and here's just a quick overview of these. So when I call combiner displays, there's variations in the light sources and the way they do the optics, but basically you'll have an image source, a set of complicated optics, and your image will be typically presented through a silvered mirror so that it can be reflected to the user as if it was collimated, means so it's parallel light, and shown to the user at wherever you want to focus that information based on your optics. Here's some images of transparent displays. You'll see much more use of color, but also a lot more issues with transparency in these displays. Their typical application is more of a commercial use, marketing or advertising, rather than a transportation use. And here you see head-worn display options and some of the variations here. You guys might recognize this guy on the left here. You shouldn't have done that, Sam. And they range from commercial glasses to sophisticated helmet-mounted displays. Okay, so those are your three basic options, and here are some of the main challenges that have to be dealt with. Challenge number one, conformal information. That means showing things where they appear in reality and making the user see them where they're supposed to be. That's one of the biggest challenges, and I'll talk more about that later. The legibility or the visibility of your information, both what you're presenting and what you're doing to the view outside. And these are issues like luminance contrast. Is it bright enough to see? Is it too bright at night? Questions such as that. The transparency of your display, can you see through it and see the information you want to see outside? Distortion by the display. The resolution of your information, is it readable? And also the size of the image that you're able to present to the user. And I'll talk more about that in a second. Your field of view that's available. So these are the three primary issues, and some other supplemental issues you have. You need to accommodate for movement, specifically of the shift, listing, rolling, all the things that make your image move. You need to integrate those into your software. And then there's the movement of the user themselves. Typical bridge context is not a very static job. Can that be accommodated? Typically, most of these systems have an eye box, a place where you can stand and see this information accurately where it's supposed to be. Cost and installation requirements, both for the research purposes and for onboard purposes, are a big consideration. Will the mariners accept this technology? Questions of the content and the symbology. Color is a big issue here. If you use it or not, it depends on how you have to create your symbology to still make it understandable. And I'll talk about that again in a second. And then things about the task and the context-specific needs for this kind of information. Okay, some of these are rather straightforward, like legibility. There's three of them that are a little more complicated. I'm going to revisit here really quickly. So collimated and conformal information. Collimated means to make your light parallel so that your eye can focus out at infinity. And conformal means to present things in the real world where they belong. So if that buoy is there and you're augmenting this buoy, your information is where it belongs in the world, or for this other target ship. This is one of the true benefits of head-up information. That's what makes it a truly advanced technology, would be to incorporate this kind of information for obstacles, traffic lanes, other vessels, where they are out the window, where they're supposed to be, augmented with information as required. To do this, you need to focus this information where the eye is focused to see these objects naturally. And for the mariner, it's complicated to get the optics, but for the mariner, most objects of interest are more than 6 to 9 meters away, and your eye cannot focus farther than that. Everything past 9 meters, your eye is at its limit of relaxing the muscle, and you can basically focus on all things past that point equally. So if we can present this information so it appears past 9 meters, then it can be focused on concurrently with the information in the real world. Okay? I put this on there just because people kind of forget. A lot of times we're talking about 20 degrees of vision here, and that's between 100 and 80. Think about, from the task of a mariner, how much of your critical information is only in this 20 degrees in front of you? And is that acceptable for the information we would want to present? Okay, so color, I talked about color a little bit earlier. everybody thinks, as you saw in the demonstration in the simulator center, if you were there, we use color to present this head-up display information. There's pros to that. It's a familiar coding for the Mariner, red, green buoys, the color of your track line. It's very effective as a coding mechanism. It also gives you a lot more flexibility in both your symbology and how you display it. But you need to also consider that when dealing with head-up information, there's several cons that come with it as well. If you're presenting color on a background that is colored and changes color, you affect both the color of your symbology and the color of your background. As you've seen, most aviation head-up displays are in this bright green color. It's a very characteristic color. Everything in bright green, you are very clear that that belongs to your head-up information and not to your outside world. As you start to use more colors, you start to blur the line between what is head-up information and what is in the world. That's what we call the HUD gestalt. Combiner displays, what I was talking about earlier, to show this information through the optics, they need to reflect that spectrum of light. As you start to show more colors, you start to block more spectrums of light. You start to ruin, or not ruin, degrade the ability to see through the clear display that they're looking through. Further, when you're presenting head-up information, its symbology is more in the terms of lines and outlines. You're not putting in filled-in objects as much. That's a pretty bad idea when it comes to head-up information. Okay, so now I presented the problems, I presented the options. Now I'm going to go through the options again and talk about the pros and cons of each as an option for doing this on board for Mariners. So combiner-based head-up displays, these are the kind you're seeing on aviation HUDs and most of the automobile HUDs these days. Infinity focus, conformal information, it's been proven that you can do this. This is achievable. Various lenses, mirrors, and coatings, different ways to do that, but it is doable. Legibility and visibility are satisfactory. The size, the field of view is typically very limited in these displays, 15 to 30 degrees. And that's for systems that are placed very close to people's eyes. You've seen the aviation pilot with the fold-down HUD. It's right here. So your field of vision from that same size display is going to be bigger than if you're standing back here trying to look through the same display. There is potential for larger display surfaces, but from talking to manufacturers, that has a big impact on both cost and legibility. Think when you blow up a grainy JPEG, how it starts to be pixelated. So the ideal world would be the size of a bridge window, but it's going to take some work to get to that point. Movement, stabilization, the ship movement can be worked into the software code and solved by various sensors. That is not a problem. The viewer itself is combined to the iBox. For all the systems that exist right now, you need to be in a certain location, and that can be variable depending on the optics involved. But outside of that, the information is not accurate to the real world. In combiner-based displays, color is not a good option. I talked about that earlier. And the cost of these systems is very high. They talk more and more about reduced cost head-up displays, these combiner-based ones, and their target goal for those is less than $50,000. But even those installed typically run about $150,000. And the typical standard system is anywhere from $250,000 to $450,000. That's definitely exclusive for research purposes, and I would pretty confidently argue that would rule out most maritime users for wanting to incorporate something like that on their system or on their bridge. Okay, so combiner-based displays. Next one, transparent display HUDs, or head-up displays. The big issue with these is you can typically not collimate them and focus the user at infinity because this information is produced in the display. Therefore, the person's focusing at that level. And there you run a bigger risk of this attention capture and not seeing the things out the window that you want to see because your eyes tend to be pulled to the closer focal point, especially when it's showing color and other things. You can fake this view at out farther, so this stereoscopic view, and get the 3D effect, but that is not typically what we're shooting for here with presenting information at infinity. There is the potential to include optical components, either making the display itself in the shape of a lens or as a lens or putting something in between, but this hasn't really been tested yet. What the impact on the light from outside would be as well would need to be evaluated, and then the cost would also probably increase significantly because the optics are what tends to be very costly. Again, remember, most of these transparent displays aren't being made for maritime head-up display or any head-up display use. They have other intended target groups. Legibility, visibility is a problem with a lot of these transparent displays. Seeing through them, 60% was the standard on a lot of them. So display and resolution. Okay, field of view would only be limited by your display size. There are larger displays that exist, mostly with limited resolution. Movement, we have the same issue. Stabilization is not a problem. If you're going to show conformal information and use optics, the viewer would be constrained to the eye box. Otherwise, there is more variability in being able to view the information accurately from multiple positions. Colors available. The cost is significantly lower, but availability is very limited. For instance, Samsung's been coming out with a transparent display commercially for, I don't know, Sam, was it 5 or 6 years? We still haven't seen it commercially. If you start to include these optical components, you're probably going to increase the cost significantly. Okay. The next one, head-worn displays. The advanced version of these can support conformal information. That's been proven several times. They've even advanced to the point where they can focus your presented information wherever it is you happen to be looking at the time. The commercial applications aren't as good at this. For instance, Google Glass has very limited support for conformal information because all your information is presented in your upper right corner. So we need to look at whether or not we can trick it into doing this augmented reality conformal information presentation. Legibility, visibility is typically acceptable with these systems. The field of view is largely dependent on your system. Is it one eye or is it two eye? And then how much is available in that system. Glasses average about 20 degrees. You have professional systems getting up to 150 degrees. But that's kind of balanced off by the fact that it can track your movement, and wherever you're looking, you're getting that information. It requires motion tracking. You can look in all directions. Some comparison studies found the accuracy of the head-mounted or helmet-mounted displays to be lower than the fixed position ones, and a lot of that's because of the movement and the slips and trying to keep up with these rapid movements. Color is possible, but it's going to depend on your optics, and when you get to this collimated conformal information, you've probably ruled out color at that point. The basic overall guiding principle is, unless you can display a pressing need for color in this head-up information, you should probably avoid using it. Cost for the head-worn displays is much lower than the other ones, and that's why it's a viable option to start testing some of these concepts. Commercial, you can get them now between $400 and $3,500 that are available for showing augmented reality information. The biggest issue with the head-worn displays is actually mariner acceptance. They do not want to wear anything bigger than a set of glasses, and that doesn't mean Google glasses, that just means a normal pair of glasses. And then it also requires additional tracking components. If you want this system to work accurately, it needs to know where you are and where you're looking, and that adds additional items that you have to deal with and wear. Okay? There's other ways to address that, but conclusions. Okay. To push this farther in research, to push this on board, we need to find a display that can produce conformal information, and this information has to be legible and visible. That automatically limits some of the options available. For the near future, we're going to have to deal with the sizes that are available to continue to test this proof of concept and see what are the limitations of that. Is that enough for the mariner? Do they need more field of view? Do they need a wider display? Do they need more colors? What it is that actually makes the system viable for the maritime user. Movement can be handled from factors of ship movement, gyros and other things can be used. That can be dealt with. Initial testing is probably not going to be with a mobile mariner. To at least prove the initial concept, starting with a seated user, such as a high-speed vessel user, or with an assigned position where this information is valid for a single user, that would be enough to get this concept moving farther forward. Cost is a big kicker with this. It's very prohibitive unless you have a manufacturer involved of the optical components or the HUD, especially for research purposes, but that goes even more so when you want to bring this on the bridge. Looking at the different kinds of operations, only certain types of vessel operators or owners are the ones that are willing to spend money on something that is not essential or not required. Okay, in a nutshell, that was an overview of the options. Again, the goal is to look at how to further this conceptual research down the road to getting it something that mariners could actually use. Okay?
Okay, if Joe Ryan, Margarita, and Michael Bergman. Okay, while Margarita is coming up, just a few introductory remarks. I took some notes during the presentation. Was that a hint? I took some notes during the presentations. I found a number of things quite interesting. I would love to be able to find a few more details, but the benefit of the panel discussion is to respond to questions or comments from you, not me. So I would encourage you to ask questions or provide comments, because if you don't, then you're stuck with the fact that I will. Okay? So I'm going to sit down at the very far end there. Hopefully I won't have to facilitate much of a discussion, but we will open this up to questions or comments. We also have the technology, with the exception of Joe Ryan and his infallible memory, to call up some of the slides from the presentations if you have particular comments about some of the things that were shown as part of these human-centered design or human-centered displays or machine interface type of issues. Okay?
Okay.
Okay.
All right. Oh, thank you. Dr. Holder, if I may, I'm reminded of the cell phone camera where you also have the flip version where you can take a selfie or you're actually seeing what's behind with a normal photo. And I assume that there are actually two options, and maybe you can clarify it for me, because I'm thinking of the movie Prometheus, where their heads-up display is always very available, very easy to use in a Hollywood setting. For some of us, it does appear like a little science fiction. So is it possible to have a camera, like on the cell phone, that actually is mounted to the bridge, forward section where the windows are, and have that used as your picture, and then use just computer screens as the item that you would say is the digital display, rather than the other way around, which I guess is the more conventional way of looking at HUD?
Two ways to answer your question. What you're asking already exists. Chuck behind you there already makes a system like that, where it's video-based augmented reality.
Okay.
And for me, that's, for head-up display, I actually want to see the real world. But there's actually applications where it makes a lot of sense with a night or this forward-looking infrared radar. There's other situations, but I wouldn't label them directly a head-up display. It's more video augmented reality. But there's uses for that. There's definitely, but these systems do exist. I think Chuck could give you a pretty good overview of them. We tested our simulated HUD with some of the augmented reality video systems as part of this testing through the simulator. I can try, Lee. Augmented reality, there's reality out your window. So in you guys' case, us at the panel, if our names were above our heads, you would be augmenting the reality you see with additional information. So it would say Michael, Margarita, Eric, Joe. That would be augmenting what you see with information over the reality. I'm assuming you guys all see this. Does it change the reality though? It can change it, but in theory, it doesn't have to. The point, you're augmenting it. You could outline something, and then you're adding information over reality.
Okay, if I add a vertical dimension, exaggerated 6 times over, is that augmented reality or is that distortion? That's distortion.
You're just putting clutter in my view. In that case.
Clutter makes it more interesting by some people.
Okay. Well, there's a whole world of gaming and other augmented reality where the things that don't exist are there, or things that aren't useful to everyday tasks. But sorry, augmented reality means putting extra information over reality. You can choose to put what you want on that, but for a specific task and a specific use, it's more thinking what's useful to these people, so.
Yeah, first of all, to your question, actually, we had on the aviation side, there were a lot of experiments with with aircrafts without windows, because windows are very difficult construction part of the aircraft that has not survived, mainly not because of technical inabilities. Of course, you can have projectors which are projecting what is out there, but for psychological reasons, for the pilots in the cockpits. And so it is possible, yes, there are systems out there which are building up. It depends on the situation you're in and what you're doing. In other areas, it's actually quite useful. You have it in some fighters and some special tasks when you have infrared information being overlaid to give you a better picture than what you could see with your own eyes, and you have a different impression. So I think it's very much depending on what is the application you want to use it for. In respect of augmented reality, I think one have to remember when we talk about augmented reality, we are talking about reality, and we are not talking about fiction. So it still needs to be reality, and the reality needs to be visualized. So going a little bit back, what I see, ultimately it needs to be the information which increases your knowledge. And if the augmentation is actually distorting you, then you have less information available, and that is counterproductive. So it actually, what you see may no longer be reality. It may be a vision of a fiction of reality, and that is counterproductive.
Going down the same line and perhaps describing it in Chuck, I'll shout out to you as well. In terms of advantage and disadvantage of things, as a traditional master mariner, I tend to look at things, and even in my role in RTCM, tend to look at things as, all right, what do we have, and how do we make use of the tools that we have? One of the things that exists out there in the classification world is called electro-optical video systems, EVS. These are mandated in a bridge design which has a 360-degree view requirement, and several classification societies, I believe DNV and American Bureau of Shipping, and I think the ISO is actually considering adoption of them, where these are already installed on ships with 360-degree view and integrated bridge systems. And so you have the basic thing is, in looking through windows, if you have a place where you have blockage, there needs to be a camera to provide you with a screen to duplicate what you would be seeing through that window. And that would be a very good feed, for example, into your stuff, Chuck, as part of the augmented reality piece. And from a bridge work versus, and perhaps more acceptable to the mariners who are looking at integrated bridges and ecdysis and radars and walking around the bridges, than the, wearing the piece. There's an advantage, for example, in your iBox piece with respect to a conning position. But I don't know how much time, Marguerite, how much time do you actually spend at that conning position? And so in looking out in that terms, the augmented reality may be more acceptable to the mariner than the actual heads-up display technology for that part of a solution. And maybe the right thing, reaching back to Lee's prior saying, one of the first problems is you're not looking at the situation from the bridge of the ship. Really, is it the mariner's reality that you need to augment, or the ship's reality that you need to augment? Because you may, if you refocus it perhaps from, I'm providing the information to the mariner from the point of view of the vessel, might be something that is directly acceptable to the user, and also useful to transient mariners, like our pilots when they come aboard. So they have the same piece. It doesn't have to be mariner-specific. It's mariner generic and ship-specific. Do you think I said that properly, Marguerite? So, thank you.
Yeah, my name's Chuck Benton. I have a company, Technology Systems, and we've been doing augmented reality projects with the Navy and others for a while now. Absolutely. I originally, or in an earlier life, was involved a lot with virtual reality, and the simulators we were looking at yesterday have a high-fidelity simulation of reality. Everything's in the right spot. It's not stretched out like the example that you had given with the depth issues and whatnot. And what augmented reality is taking virtual reality and mixing it with the real world. And what you need to do is to make sure that what you're using as your virtual reality elements within the augmented reality have high fidelity. If they don't have high fidelity, it's not worth doing things. So what we do...
You still lost me. What's the difference between augmented reality and virtual reality?
If you accept the virtual reality is a 100% computer-generated representation of the real world. So in other words, your high-fidelity simulator. Now you go out into the real world, and you're looking at the real world, so that's 100% real world. And now just start adding elements from your virtual reality selectively. So for instance, you start adding navigation aids. So now when you look out into the real world, you see the real navigation aid, but using some mechanism to overlay computer-generated imagery. You also see a virtual element. Now the fog comes in, you can still see where that nav aid is. So what we've ended up doing in our systems is we use a video camera off to a display. We don't recommend that users look at the display and use that as their real-world view of the world. What we instead do is give them a cueing mechanism. So now they can look and see where buoys should be, where ARPA targets might be, and then lift their head up, look into the real world, and know where they should be looking to see what it is that they're interested in.
Everybody get all of this? Want to deal with this that's lost?
Let me give a piece of clarification. Okay, in one of Chuck's earlier pieces, which I saw several years ago, you had the camera picture, if you will, of I'm looking out at the buoy. And the augmentation was a symbol of the buoy, basically plotted, if you will, in the virtual image right on top of the buoy. So, but, well, one was being pulled from the charted data and overlaid the actual physical image of the buoy on the camera image. Is that described well, Chuck?
That's it exactly, and it's interesting. The Coast Guard at one point was looking at this and saying, well, how do we know that your virtual buoys are actually in the right spot? And we're putting the virtual buoy where the chart data reflects it's supposed to be, which is where the Coast Guard believes they dropped the anchor, but then it's on station going back and forth. And it's interesting because you come into a harbor, and during the flood, all the real buoys are north of where the virtual, or inland of where the virtual buoys are, and during the ebb, they're all the other way down. And some of the Coast Guard folks then said, well, gee, this is interesting. Now we can tell when our buoys are off station.
If I'm the only one confused still between real, virtual, and augmented, then so be it. But it's like two guys standing on the corner, both claiming to be Jesus. One of them has got to be wrong. Think about it. It's not replacing reality.
Actually, the,
you don't want to be doing visual navigation and don't want to run over the buoy.
Thanks. A different subject. I have a question for the panel, but maybe specifically Margarita and Michael. Human-centered design, usability is not new. It's been around for quite a while. We've had usability clauses in SOLAS Chapter 5. We've had all the class societies doing good ergonomic design guidance. Why now would a guideline on human-centered design take hold in the maritime industry, and what can we do to ensure that it does? Because a guideline is just a guideline, and if there's no inspiration to do it, it's a very complicated procedure.
Okay, first of all, human-centered design is something which is developing, which has evolved over the last 20-some years. And usability and user-centric design are different pieces. User-centered design gives you guidelines. How do you design and develop things so they are usable? Usability studies are then testing whether the final product is actually usable. Human-centered design is intended to make things usable. Usability is proving that it is usable. So these are different viewpoints, one from the one side, one from the other side. So they are not exclusive to each other, they are just enhancing each other. And the human-centered design, what you have seen in Margarita's and my presentation, that is something which has developed in the last, I would say, about 10 years, where it started to get more and more academic research pulled into reality. And in the but that is for the more or less last 10 years. It started to find its way from a pure academic view to the industrial view, getting that into products and making sure products are utilizing human-centered design. So the real benefit I see from human-centered design being part of the strategic implementation plan, being part of e-navigation, is that we actually have an IMO recommendation to ensure that during the design of a product, you're ensuring that the usability will prove it to be correct.
How do we get them to use it? Is that the question? Yeah. I think David was asking, how do we get them to use it, because it's only a guideline.
Okay. Good. So that is the one aspect. Now, what I was saying is that industry does need to produce products which are usable. If we are producing products which are not usable, we cannot sell that. Now, if we have a guideline, if IMO puts out a guideline, that is something which we as industry, and I can confirm that with all the members of CRM, we are looking into that carefully to say, what do they want to tell us with that? And we will take that in consideration. Now, the individual interpretation of human-centered design, how you integrate that in your design models and in your development models, that may be different from company to company. But the concept itself is something which is already accepted by industry. It's just validated by IMO in the human-centered design guidelines that it is to be used. So I do not see any problems with actually utilizing that. Well, you know, it's like a chicken and egg. I think the concept already has taken traction. Industry does use human-centered design right now. So the recognition of IMO having a guideline of human-centered design is ensuring, validating that, and gives it another speed, so to speak. But industry is already using human-centered design. As you have the guidelines, the individual companies will actually review their own human-centered design guidelines they have and see, does it align with that, and if not, can we learn something what is actually pulled together by experts within the different working groups in IMO, and that is what I see as the positive item.
I think Michael's right. I mean, the industry's been using human-centered design for years. It's really an outcropping of technological innovation. But there is a difference in IMO recognition and call-out, because basic designs, if you go back to radar systems and even perhaps to a lesser extent, but even ECDIS, the designs at those times, 25 years ago, 50 years ago, these were really based on for example, the radar coming out of World War II, based on somebody sitting and operating a radar system, based on the World War II requirements for a radarman to be sitting there and doing his job in order to provide the fire control people what they needed. That's obviously not the use on a commercial ship. And it's taken a long time for IMO to figure out that technology moves and technology is not immediately adaptable. The concept of operation for use of radar on a warship is very different from the concept of operation of use of radar on a commercial ship. In a modern example, if you're on a Coast Guard cutter and you're intending to board somebody, you want to intercept them. If you're on a commercial ship, you want to avoid them. And same mathematics operate in a completely different user manner. So the adaptation, I think Michael is right on spot. What you really have is kind of IMO recognizing that human-centered design is employed, but wait a minute, we need to properly define the user as the mariner, not a console operator.
Captain Grubbs, Douglas Grubbs.
Thank you, Lee. This was a good forum, really good. I sincerely appreciate every one of the presentations, and so I won't be too big of a cynic here, but you need a reality check, except for Joe. Joe's got it. Joe's got it. And the reality check is, I was a very young pilot, 45 or longer, years ago. Old Greek had been running New Orleans since the early 30s, and we were discussing accident investigations. The NTSB was growing in those days. And he said, Mr. Pilot, it's not who's right or who's wrong, it's who pays. Same thing with the virtual and all the, we, the pilots, have a lot of experience with virtual stuff. And it is very, very expensive, because it's not, it sounds simple, it's like your iPhone, but when you start putting dots on a chart, and you get a whole group of, we have 300-something pilots in the river, or you start throwing it out to the industry and say, well, that's really a buoy. You know, what we had to do was to model everything, resurvey the river, and most people don't have that. It's very expensive. And resurvey the hydro, and resurvey the wires, and have some smart people from the Corps of Engineers place these virtual buoys in a polygon to make sure you get the proper drift angle on it. You could swing the big stacks out onto the part that they could clear. And the passengers thought this was great. But the amount of money it costs to get pilots who are got kind of the high end of the spectrum to really buy into this. And most of them really didn't even buy in. They did it because a few people said, this can be done. But when you start putting glasses on people, it's not that simple. You're going to have to convince those people that it works, whether it's reality or virtual reality or it really is going to take a lot. A few people will do it. I don't know where your market research is at. A few people might do it, but most people will not. I promise you that. I go back to my human factors people, and I'm just super, super impressed with both of those presentations. And in this world, you know, your equipment, I'm really amazed there's a radar company out there that says, well, I want to pay attention to what they can actually absorb. I mean, in this virtual reality world, Costco Busan, I know the pilot was whatever, he was drugged, whatever he was. Also, they had a new crew on there, and that Ectus was on automatic. They didn't like it. He kept trying to adjust it. He didn't understand it. And it kept going, and it was changing modes on him. So, you get back to the human factors. You can put all the equipment out there you want, but it's going to be, Michael, I'm sorry, but the doctor / CEO and captain, it's going to go back to you guys to figure out how can you make this as fail-safe as possible. And I don't know if that's impossible or not. But my question is, what do you think can be done to train people to accept this ENAV type of data fusion in this new world of navigation? That's, you know, how would you do that at the various levels of intelligence and competence?
In the best of worlds, with a good design, you wouldn't have to train people. You wouldn't have to train people if the design was perfect. We're never going to get there, but if it's, let's call it intuitive, for lack of a better word. And then what you were talking about is more of getting people to accept change, which is, I think, a very difficult psychological phenomenon.
So from my point of view, very good points. That is actually what we are struggling with when we are trying to commercialize a product which is well designed and is working well. Then you have to deal with different levels of education, with different cultures, what I tried to mention yesterday, different cultures, different understandings, different view of things. So that somehow, that is part of the human-centered design, to take in account who will be the final users. And you're not only selecting your users based on what you like to implement, you have to get a broad picture of all the users of the system to see how does it work. So a well-educated mariner coming out of CMA is something different than a half-educated mariner coming from, I do not want to know to mention countries, but some countries which do not necessarily have the capacity to train like that, but they also need to manage with that. So you need to keep that in mind, and that is part of the human-centered design. So you can develop something where you say, I select my users so they agree to what I want to implement. That is not what is human-centered design. That's the one piece. The other piece is that you may have different modes of operations depending on your maturity, so to speak, and you have to train. So there's nothing like error-free software. There's nothing like perfectly designed applications. So you have to also take in account that you may have different modes of operations, so to speak, and you have this in all kind of different areas that you have an expert mode. You can do much more when you are on a computer science on your computer than what you do as a regular user. You have different modes of operating a Word document depending on whether you are an expert in managing Word or Excel, or you are a regular user. And I think we have to build certain of those components in our human-centered design concept to say, depending on what you do, there are certain things which you may avoid until you really know what you do. Customizing an Actus display, you have to know what you're doing. Otherwise, you go into the standard mode and you have your standard displays. These are the type of things which we have to develop further based on the human-centered design guidelines to develop the systems in the future which is scalable enough to give experts user, which are in more condensed areas, more difficult areas, the necessary information they have, and others, the limited information they need to make the right decision. It's all about these pyramid I have. Depending on where the user is, the information may be different, or the combination of information may be different, so it reaches the brain of the individual person.
And if you're talking about user-centered design, if you want the buy-in from the users, you have to build something that they want. So if you can show a value by what you're building, particularly by talking to them in the beginning of the process and getting something that they actually want, and you see this really well with the Canadian Coast Guard and the pilots up there. They were involved in the design of their tools from the beginning, and they ended up with something they want. And now that's, other people are seeing it and they want to use it because it's showing a value that other people want that value, need, exactly. Something useful. If you build something useful, people will want to use it or find a way to use it within or outside the regulations.
Made reference to the Costco Busan and Captain Coda. One of the factors that confused him was the use of ECDIS simplified symbology, which was added back in the early 90s because hydrographers decided that there needed to be a more user-friendly symbol set than the traditional charted symbology. And the fact that that was a point of confusion for a experienced pilot, and Lee said to me just earlier that he still doesn't know anyone who uses the simplified. I've never met anyone who uses the simplified symbology. I can't stand it, but it was supposedly added as user-centric and ergonomic. And that's what happens if the wrong user is involved in the user-centric design.
We are running out of time, but I want to address Captain Grubbs' comments and give him, everyone, Douglas, of course, is entitled to my point of view, right? My opinion. I have still heartburn over the difference between so-called virtual and real. Traffic separation scheme is real. It does not exist in the physical world other than on a chart or electronic chart. So we need to make a distinction between something that physically exists, and when I say aid to navigation, most people think of a buoy, a beacon, or a lighthouse. But when you start depicting that, whether you call it virtual AtoN or synthetic AtoN or augmented reality, you have to be careful as to what are we talking about and how does this compare with something that physically exists. When Douglas asked, and I already know the answer, but I'm going to make a point, how should you use this? How should we use these new technologies to better enhance our ability to perform our job to navigate safely? Well, navigation bases on two things: current situation and task at hand. Current situation can mean you're out in the middle of the ocean. There is nobody else around. It is crystal clear. You don't have to worry about grounding avoidance because you've only got about 6,000 meters beneath your keel. On the other hand, you enter port, low visibility, high winds, lots of other vessels, and your equipment begins to fail. You got a different task at hand. You also have a different situation. So if anything, you need something that you can use for decision support. And I'll use a quick example that all of you can relate to, because pilots already basically use it, and that's the portable GPS you put in your car. I use it because why? It tells me time to go, time to turn, distance to go, which lane to be in. And I can also tell you it has greatly benefited my marriage, that I don't have to depend on my wife for map directions, okay? But it tells me what I need to know, when I need to know it, and there's nothing virtual. It's telling me what really is. Okay, we're almost out of time.
One more quick question. I got the microphone, so I figured I should.
You're so far back, I think you're in another county.
I'm sorry, I'll be quick. I wanted to say that I really appreciate Dr. Lutzoff and Michael's comments regarding the need to watch, analyze, release a prototype, analyze some more, and if that were the practice, your question regarding reality and virtual reality wouldn't even be a question because you would already know. The problem that I see is that we're not doing what Michael and Dr. Lutzoff are talking about. We're trying to describe complex concepts without having prototyped them in a real operational setting. If the doctor and Michael were to watch a ship crew operate underway and analyze this for a period and then show the crew how an augmented reality or a virtual reality for training purposes or augmented reality for operational purposes would help them, it would be glaringly obvious. There would be no debate over it because you would agree, like you do with the GPS in the car, which, by the way, is augmented reality. It's showing you the road ahead as you see the road ahead, so it's kind of augmenting your reality. But I think we wouldn't be asking these questions. And Captain Grubbs, I really appreciate his reality check on the cost. This is sort of related, but a separate topic in a way. The cost of things in maritime is looked at totally different than the cost of things in aviation. In aviation, either you are instrument flight rules certified or you are visual flight rules certified. You can't fly in the same space if you can't afford the extra training and the extra equipment on your airplane to make it safe for you to do so. In maritime, that's not the case. The ships coming into the port of San Francisco have everything from absolutely the bare bones electronics to the top of the line electronic charting systems, and then they're using it at varying degrees. So in maritime, if you can't afford it, it doesn't mean you don't get to play with the big guys, so to speak, that can afford it. You're in the mix. In aviation, they wouldn't put someone who can't afford the highest technology in the same airspace with someone that does. And what they're doing on the Mississippi River, I think, is a perfect example of that. The cruise ship that has the enhanced systems, the enhanced training, they're using an enhanced device, they're able to play during an environmental condition that the others aren't able to play. So that's sort of VFR versus IFR, but it's not a typical practice, and it's because we're not doing what Dr. Lutzoff and Michael are saying. We're not analyzing the process and then giving the mariners something that they can either agree with or disagree with. We're giving them something, and then we're trying to do this analysis and then trying to fight the change management problems that come with that.
Okay, I would like to conclude this session. Thank all the panelists very much, and also the